guys, hope all of us are doing great. My name is Ernest and this is Ernest Science and Mathematics TV channel. In this particular discussion, I'm going to look at a concept in statistics, and this is going to be basically concerning with a degree of bigotness of a particular distribution. Now, in this particular case, I'd said that we can give graphical representations in terms of graphs for various sets of data, and of course, that's going to be using this specific distribution which are basically given in terms of a general representation for x and y for the two variables. And of course, for a data which is going to have this specific central maximum being displayed at this specific point, we had said that this is going to be given as a normal distribution. Now, in case we have some specific set of data which has got departure from symmetry either towards the right or left from this central maximum, that is going to be giving us the degree of departure from the central maximum. Of course, that's going to be defining the concept of skewness. Therefore, I mentioned the concept of skewness being the degree of symmetry or departure from this symmetry or distribution. Now, in this case, this was mainly concerned with a shape of a particular curve. And we're going to look at a different set of, or rather a different way of describing this specific distribution using the concept of bigotness. And of course, this is going to be dictating on how sharp a particular curve is. Now, suppose we have a specific or a general distribution given in this particular term. So we're going to have this normal distribution given in terms of this particular curve for the comparison of these two variables for a specific set of data. And if you have the central maximum being given at this specific point, perhaps we're going to have a particular distribution, perhaps shown using that specific curve. And perhaps I can have a rather more bigger one so that we can do a convenient comparison from there. So suppose we have two variables which are being compared for a specific set of data. We can have this specific distribution being given as such, and I will see that if the departure from the right or left is equivalent of both or even, then therefore we're going to have a symmetrical kind of a distribution given as such. And if we have a specific set of distribution that's going to display a high sense of bigotness, then therefore the degree of bigotness is going to be referring to the concept of kurtosis, and therefore we can have either a high bigotness or a moderate bigotness or a low bigotness given in this particular case as such. So if we try to look at this, there are various names that we're going to refer to this specific sets of bigotness, and this is going to be concerning the concept of kurtosis. And therefore we can define kurtosis as the degree of bigotness of a distribution, and of course this is going to be looked at in comparison with the normal distribution, which I've basically given, especially on the middle part of this one, which is a curve that of course drawn in my first case. Now in this case, there are various names we can give these different types of curves which are showing various range of bigotness. And for the first one, for a distribution that is having this higher kind of a peak, we're going to refer to it as leptokurtic or leptokurtic given as such. So basically this is going to be a high peak or displaying the concept of a high bigotness given as such. And then if we're going to have a moderate one, that's of course being given in this particular case for a normal distribution, we're going to give this one as a mesokurtic or mesokurtic given as such, and this is going to be a moderate bigotness given as such. And for a high, a lowly bigotness, or the one that is going to be showing some nature of a flat top or a plateau one, flat top, this is going to be given a term of a platykurtic or platykurtic given as such. So these are various names that we're going to encounter in our description of various aspects of kurtosis. And these are going to be displaying the high bigotness, the moderate, and of course the low bigotness or the flat-topped kind of distribution that we're going to see being displayed in our various descriptions. Now in this case, similar to of course skewness, we're going to have a various range of methods of trying to measure this concept of kurtosis. And in this case, I look at the concept of moment coefficient of kurtosis, and that's going to give us a clue on how we can describe various types of curves from this particular sense of the degree of pickedness. Now in this case, we're going to have the moment coefficient of kurtosis or kurtosis as one of the methods used to measure this degree of pickedness, which I've given. So this is denoted by a symbol. So we have said that skewness is given this specific symbol. So for kurtosis, this is going to be given this symbol, and this is equivalent to the ratio between the fourth moment about the mean divided by the square of the second moment about the mean given in this specific case. But remember from our last discussion, I basically mentioned that this population variance is going to be given in that particular case, and this is going to depict the second moment about the mean given as such. Therefore, we're going to have a second aspect of this specific measure of kurtosis given in terms of the fourth moment about the mean divided by that specific square of this population variance, which is going to be given as the fourth square given as such. And of course, I've elaborated in this specific case, and I said that basically M4 is representing the fourth moment about the mean, and then M2 represent the second moment about the mean. And I've said this one, of course, basically is going to represent the population standard deviation. We also square is basically going to represent what we refer to as the population variance, and also, of course, this specific cube is going to represent, of course, the what we refer to as the population variance, the square of the population variance given as such. Now, in this case, I have mentioned about the concept of kurtosis, and we're going to have some specific values which are going to be attached to the value of this measure of kurtosis. So, in case we have the value of this specific range for kurtosis greater than 3, this is going to display what we refer to as a leptocutic curve, given as leptocutic curve given as such. And I'd say that basically for the leptocutic curve, this is going to be a curve that is going to be displaying the high pickedness kind of characteristic. And in case we have this value of kurtosis equivalent to 3, then this is going to depict what we call a normal or a mesochatic kind of distribution, and of course that's going to be given as such. And then lastly, we're going to have this value for the kurtosis equivalent or greater than the value of 3, and this is going to imply a flat topped, or what we refer to as a platyphatic kind of curve in that specific respect. So in case we come across various terms which we have mentioned in this particular video, then we're going to remember that basically that's the degree of pickedness which is being represented in terms of kurtosis, and therefore being given the various terms which we have mentioned in this particular case. Now, in my last video, I'm going to give a specific example and perhaps give an illustration which we are going to use in order to determine the various values for the concept of skewness and kurtosis of various kinds of data. So that is it for now, guys. Bye, God bless you. Catch us in our next video.